Welcome to Chapter 6, Section 1, entitled Evaluating Nth Roots and Use Rational Exponents. It's a bit of a mouthful. Now, some of these are your vocabulary words to review. The nth root of a. Remember, if you're given an n, like 2, and you're given an a, like, 8, that would mean the second root of 8. So you would set up the radical, put a 2 in there, and put 8. Now mathematicians are pretty lazy. You don't need a 2. You don't need it if it's a 2. The index of the radical, please remember, is the number in the v. So the number in here, the index of the radical is right here. And then inside the radical is the radicand. So let's take a look at the right here. So let n, if n is an integer, and n is an even integer and odd integer. So this is a table. It's broken in half like this. If n is an even integer and a is less than 0, no real nth root. That means an example of that would be the square root of -4. That equals 2i. It's imaginary. If n is an even integer and a is 0, that means the nth root of 0 is just 0. That means the square root of 0 is 0. If a is greater than, and it's an even root, then the answer has 2 real nth roots. That means if you did the square root of 16, it could be plus or minus 4. All right, if it's odd, if you have this, if n is odd, nth is a, you just put a 1 to the nth. If it's 0, it's 0. And if it's here, it's also still a 1 nth. So the even one is really the tricky one. You have to think about imaginary numbers and plus or minuses. So looking at this, because n is 3, n equals 3 is odd, and a is -64. Oh, -6, I'm sorry. A is -64, which is less than 0. It has one real solution. And then, of course, because -4 to the third power is -64, you can write this is equal to -4, or this is equal to -4. You can do it in both directions. Now, part B, because n is even, and a is equal to 729, which is greater than, since a is greater than, it has 2 real roots. And since three to the power of 6 is 729, and -3 to the power of 6 is -729, you can write this is equal to plus or minus 3. It's basically helping you get an idea of what your answer should look like. So here, a fourth root of a positive number, that would be 2 reals. A cube root of a positive number would be 1 real. And it would be the nth root of 256. And the nth root of 512. Well, this right here ends up, you should know that 256 is 4 to the power 4. So this is 4, and the 512 is 8. All right, guided practices number 1 tells us that n is 4, a is 625. So the question says, oh, back to here a second. I'd be very angry with you if you forgot this. It's 2 reals plus or minus 4. 1 real, only positive 8. Here, since it's even and it's greater than 0, you have 2 reals. Therefore, the nth root is the fourth root of 625, which becomes plus or minus 5. That means 5 to the fourth is 625, negative 5 to the fourth is 625. Look at number 2. Number 2 is n is 6, a is 64. So, even, greater than 0, that means 2 reals. The 6th root of 64 plus or minus 2. All right, let's give number 3 a shot. Number 3 says n is 3, and a is negative 64. So since it's odd and greater than 0, you're going to say 1 real. And it will be the cubed root of negative 64, which is only 1 real solution, which is 4. Negative 4. All right, now, we did this in the class, or we did this earlier in the video, but didn't explain why. Fraction exponents are radicals. Okay? Fraction exponents are radicals. So basically, oh, and I guess we didn't talk about this too much. That means the nth root of a can be written as a to the, there's a 1 right here, so it can be 1 over n. If you had the nth root of a squared, you would have a to the 2 over n. The index equals the denominator. The exponent on the radicand is the numerator. All right? So right here, and both ways, it works both ways. Okay? So right here, numerator. Hold on a second. So if you have the fourth root of a to the third. The numerator is on the radicand. The denominator is the index. And it works both directions. The numerator goes on the radicand. The denominator goes in the v as the index. So I'd watch that a couple times, make sure you understand what that means. So right here, though, we can use properties of exponents to rewrite some of these equations if you want. A to the 1/nth is a radical, and it's the inside it's the index is the denominator. So you can rewrite things as much as you want. Sometimes one way will look better and act better than another. And of course, don't forget the negative exponent that goes in the denominator. All right. So these should help us now with the next group of problems. All right. So now we're going to use those properties, that idea, to rewrite from rational exponent form to radical form. So this right here, rational exponent form, can be written a few different ways. Like, we might not know what this right here is equal to, but I can rewrite this radical as 8 to the 1/3 and then -4 on the top. Now the reason I want to do this 1/3 is it does become a little bit easier. 8 to the 1/3. 8 to the 1/3 is 2 to the -4. Negative exponent property says you drop that down, make the exponent positive, and 2 to the 4th is 16. Now radical form involves making it into a radical. That's the cube root of 8 to the -4. Well, I don't know what 8 to the -4 is, so I'll rewrite it as the cube root of 8 to the -4 on the outside. And now you should start to see that this ends up being the exact same solution, just viewed in a different way. So let's go ahead and solve some of these equations. And let me add in here that you undo fraction exponents by, or with, undo fraction exponents with reciprocal fraction exponents. That means in x to the 1/2, you undo the 1/2 exponent with the reciprocal, 2 over 1. You have x to the 3/4. You undo this with a 4 to the 3rds. And please remember, when you undo equations, you're undoing PEMDAS. All right? So, undo multiplication first. Oh, and let me actually add one more thing here. Undo fraction exponents, reciprocal fraction, or undo nice exponents with roots of the same number. That means x to the sixth is undone by the sixth root. X squared is undone by the square root. Right? All of those uh, can work. So a sixth power is undone by a sixth root. And since it's even, you have to put the plus or minus. And it's plus or minus 3 is your answer. Up here, how do you undo a cubed power? Well, a cubed root. So you have x plus 4 equals the cube root of 12. And the cube root of 12 does not simplify a whole lot. But we do subtract 4 from both sides. And you should have that. Now, this right here, this symbol here means about or approximately. So then you would say x is approximately negative 1.7. All right, let's look at guided practice number 6. Nine to the negative 1/2. Well, negative exponent makes this 1 over 9 to the positive 1/2. And if you don't know what 1/2 is as an exponent, it is the square root of 9, which is 1/3. Number 7, 81 to the 3/4. Well, I don't know 81 to the 3/4, but I do know 81 to the 1/4. 81 to the 1/4 is 3. And you can't forget that there was a third power here. So 3 cubed is 27. Number 8, 1 to the 7/8. This is a trick question. Because 1 to the 7/8, you could say, all right, well, I know what 1 to the 1/8 is. And then to the 7th power, well, that's just 1 to the 7th, which is just 1. So that one's kind of a trick. All right, roots with calculators. All right. Hopefully at this point you know that the button that has this triangular symbol is the power button. Okay. So you can do power 3, power 4. You can do all sorts of powers if they're nice. If they're not nice, you do things like, there's a triangle button, parenthesis 1/2, triangle, parenthesis 3/4, and so on. This is how you can set it up by using your calculator. So for guided practice number 9 in your calculator, you're going to type 4, push the button 4, then hit the triangle button, then parenthesis, then do 2 divided by 5, close parenthesis, and enter. So it's 4 to the power of, should be 1.74. Number 12, you need to type it, okay, number 12 is set up so that it looks like this. The cube root of negative 30 squared. Well, we're going to use, make it turn into a fraction, negative 30 to the 1/3 squared, which becomes negative 30 to the 2/3, which means in my calculator, I'll do negative 30. So in your calculator, parenthesis, negative 30, close parenthesis, the triangle button, parenthesis, 2 divided by 3, and enter. Should give you about 9.65, approximately. All right, using population. All right, so this is models something. Substitute for C, it tells us the initial population was 75. Oops. Let's see here. Certain population of a certain animal. Okay, so C is the certain population, 75. 1.21 T over 3. And P is then the time. Ooh. So we don't know what P is. But we know that T is 19 months over 3. So in your calculator, you're going to type 75, parenthesis, 1.21, close parenthesis. You're going to use the triangle button, parenthesis, 19 divided by 3, and that will give you the approximate answer in the calculator. So give it a try and see if you get the same thing as I. So hopefully you got about 250.8. And so you can't really say 0.8, I don't think. So you'd basically say the population of the species is about 251 after 19 months. Okay, let's evaluate this. You can do it with your calculator if you want. Calculator or by hand. By hand, you'd say negative 125 to the 1/3 and square it. Well, this right here is negative 5. Squaring that gives me 25. The calculator, you'd have to type parenthesis, negative 125, close parenthesis. The little triangle button, parenthesis, negative 2 divided by 3, and you would still get 25. Let's solve this one right here. A fourth power needs one of two things. You can use a fourth root or a 1/4 power. I'm going to say for these, using a root may be better. So use a fourth root. Y minus 3 equals plus or minus fourth root of 20. And you're going to have to approximate. And you'll have two different approximations. Try to use your calculator to find those approximations. All right, so you should have a couple answers here. You should have approximately 5.11 and approximately 0.885. Let's try out this story problem. Volume of a cone is given. It says the volume is 25, whose height is 6. So plug all those numbers in there. 25 is the volume. Pi r squared, we don't know. We know h is 6 divided by 3. So we have to undo all of these operations first. So we have to undo multiplying by pi, which means divide by pi. We have to undo multiplying by 6, which means divide by 6. And we have to undo a division of 3, which means multiply by 3. So that means r squared is equivalent to 3 times 25 divided by 6 pi, which is about 4. And once we now square root, you should have that the radius is plus or minus 2. But hopefully radius plus 2 is your only logical choice. All right, just a few more guided practices here. Let's look at number 13. We have x cubed equals 64. A cubed means we cube root. X equals the cube root of 64. Now you can use the calculator, or one thing I did not mention here earlier, you may have to simplify these by using a factor tree. If we look at 64, for example, that's 8 times 8. And then 8 is 2 times 4, which is 2 times 2. All right. And now looking at this, we're looking for, since we're doing a cube root, we're looking for 3 of a kind. Here's 3. Here's 3. Okay. And that means we bring out a 2, bring out another 2, which means our answer is 4. Number 14. Half of x to the 5th equals 512. Well, we have to undo this multiplication of 1/2. So we multiply by 2. Now x to the 5th equals 1024. All right, 1024 is not going to be very fun to do the factor tree. So I would use your calculator. And find the 5th root of it. While you're using your calculator, I'm going to try to find all of the factorization. All right, so here's all of our factorizations. We're looking for the 5th root. So here's 1, 2, 3, 4. Here's 5 2's that are in common. 1, 2, 3, 4, 5. Here's another set of 5 2's in common. So that means x to the 5th is equal to 4. I'm sorry. X is equal to 4. Number 18. Solve this. Well, undo a 4th power is a 4th root. 4th root. X plus 5 is equal to the 4th root of 16. And please do not forget the plus or minus. All right, well, 16 is 4 times 4, 2, 2, 2, 2. Here is a set of 4. So x plus 5 is equal to plus or minus 2. Subtract 5. So x is equal to -5 plus or minus 2. Now, this is not the same answer with a positive or negative. It's negative 5 plus 2 or negative 5. So again, it's negative 5 plus 2 or negative 5 minus 2. So my two answers are negative 3 or negative 7. All right, so you should try the rest of the guided practices, and these will be some of the problems we do in class. Good luck.